Hello everyone, and welcome to another Algebra 1 lesson with Mr. Graves, and good to be here. We are going to talk about multiplying and dividing radical expressions. I have a couple of other videos here before this that help to kind of set some things up step by step in how to deal with radicals, but our book talks about a radical expression being an algebraic expression basically containing at least a radical or square root. So we're going to go over a few different kinds of problems here today to help you out. And so let's start first of all with the first one here. I have written actually all of these out just to save some time. We'll go step by step so you can see it and how things pan out. All right, first of all, we have the square root of 7 plus the square root of 2 times the square root of 3 minus 6. Now sometimes in our expressions, some are over the radicals and others are not. It just really depends. It can be an infinite number of kinds of problems. This happens to have, this is two sets of binomials multiplied together, where the first in each one is the radical, where the second is just a number. This one here is all radicals. This one here has at the end radicals, but in the beginning just numbers. So it could be really anything. And even over here you'll find out there's some numbers along with radicals, and then another term is just a number. So it can be all over, but our rules don't change. When we multiply two binomials, we're used to doing that with letters in basic algebra, but we don't have any letters in this one, but we treat it exactly the same. And those of you that know FOIL understand what we're doing. You also want to understand that we can stack these as well. Remember, everything that's multiplied under the radical stays under the radical. Everything that's outside of a radical stays outside of a radical. So let's do FOIL with this, and you'll understand what we're doing. F stands for first. So the multiplication of a square root of 7 times the square root of 3 is the square root of 21. Well, that's our first term. We usually do the first term first. And when we do FOIL, we actually do L for last, and we do the last term basically next. So let's do that. The last term in each one is a square root of 2 and a negative 6. Now remember, the negative 6 is not under the radical. So a positive square root 2 and a negative 6, a positive times a negative, all right, is going to be a negative right there. And then our 6 is on the outside, and our square root 2 is on the inside. I think I wrote that wrong. Sorry about that. All right, so that should be a 6 square root 2. All right, now, so negative 6 square root 2, the radical comes last, the number comes first. So square root 7 square root 3, square root 21. The last, negative 6 square root 2 goes right here, so that's the last. First, last. There's the L, there's the F. Now we do the O and the I. We do the outer and the inner. All right, it's not that difficult. Let's look at the outer. We see that we've got a negative 6 and a square root 7. So there's where our O is at. Negative 6 square root 7. All right. Now we do our inner. All right, and again, I did the rainbow. Here's the negative 6 square root 7 right there. And then on the inside, look at them. Both of them are radicals. Square root 2, square root 3 is the square root of 6. Now, when we're used to doing FOIL, we would have these be added together, but we can't do that. So we're just going to write them out, okay? Remember, they're not the same. Square root of 7 and square root of 6 are not the same like terms, so we can't add them, all right? If this happened to be a square root of 6, then we would have square root 6, square root 6. This would be an imaginary 1, and we would actually combine them to be a negative 5, negative 6 plus 1, negative 5 square root 6, but we don't have that, okay? It's very different. So we write down 21, square root of 21, minus, here's the 6 square root, negative 6 square root 7, plus square root 6, that was the inner, and then minus 6 square root 2. This is actually our answer because we have a 21, a 7, a 6, and a 2. And none of the radicals are the same for us to combine. So this is our answer. It's exactly how we write it, okay? How about this problem here? This problem has, I think it's a conjugate is the name of it. And what actually happens is a special situation that we run into when we factor. We learned this here a couple of different lessons ago. But when we have the first and last number be the same in each binomial, but the only thing that changes is a plus and minus, It's actually a perfect square, okay? Let me show you. X minus 2, x plus 2. What's FOIL? FOIL would be x times x, all right? What would the last be? Negative 2 times a positive 2, minus 49. But remember, when we do our rainbow for each one, we get a negative 2x and a positive 2x. And that scenario takes place every single time. And what does that always do to the middle? It cancels it. So we have an x squared minus 49. Well, when we see that x squared minus 49 without our binomials, we automatically know that they're perfect squares. X minus 7, x plus 7, okay? If we did FOIL the same way here, what would we have when we rainbow? A positive 7 square root 5, right here, and a negative 7 square root 5 on the inside. And they would cancel out. So what do we have? We have the first two multiplied together. So what do we have? A square root of 5 times the square root of 5. So square root of 5 squared. Well, what is the square root of 5 squared? All right, well, square root of 5 times square root of 5 is 25. 5 times 5. And the square root of 25 is 5. So we have 5. What is negative 7 times a positive 7? Well, we have 7 squared. All right, that's a negative 49. 5 minus 49 is a negative 44. Different sign. Subtract, keep the sign of the larger. Okay? Now, let's take a look at this one. This is a square root of 3 minus the square root of 2 squared. So what does that mean? Well, that basically means that whatever is in parentheses is stamped twice. So I went ahead and put them side by side and we did FOIL. So when we do FOIL, F is first, square root of 3, square root of 3. Multiply, square root of 9, which is 3. It's right here, okay? The last is a negative square root of 2, and a negative square root of 2 is going to be positive. Square root of 4, which is what? 2. Positive 2. There's the first, there's the last. How do we do the middle again? Easy. Do the outer and the inner, and then we add them, okay? What do we have here? Square root 3 and a negative square root 2. All right? So what's a positive times a negative? Well, it's a negative. What's 3 times 2? Square root of 6. Okay? Let's do the inner. It's a negative. What is the same thing? 2 and 3, square root 6. So I have a negative square root 6 and a negative square root 6. All right? Wait, what's that imaginary number that goes in front of the radical? Let's put it in there so you see it. Negative 1. Negative 1. Well, what's 1 square root 6 plus 1 square root 6? Actually, a negative 1 square root 6 plus a negative 1 square root 6 is a negative 2 square root 6. And there we go. That's our middle because we add the 2. Remember that we're combining like terms and the radicals in this situation is the same. Okay? So we simplify 3 plus 2. All right? And for whatever the reason, it looks like I put 5. All right? And that is 5. All right? Minus 2 square root 6. So that's what we have for our answer. Remember, we combine everything down. 3 plus 2 is 5. And then minus 2 square root 6, and that's our answer. We can't break it down any more than that. All right? Let's do 2 more here. 4 plus square root 3 divided by 5 plus square root 3. Now, you might remember in another lesson, we cannot have a square root or radical in the denominator. That's a no-no. So the way we cancel out a denominator, such as 5 plus square root 3, is we actually multiply both the bottom and the top by kind of its opposite or conjugate, which would be a 5 minus square root 3. So that's what we've done here. Here's our original problem, okay? So we keep the same numbers, but we make the plus a minus. Why do we do that? Well, remember over here, when we have opposites, but we've got the same terms, we come out even in that respect. So that's what we want the denominator to do, because what that'll do is it'll allow us to not have any radicals in our denominator. So let's do this. All right? Here's the original problem, okay? We're going to multiply top and bottom by 5 minus square root 3, 5 minus square root 3, okay? This here is the top part, all right? So 4 plus the square root of 3 times 5 minus the square root of 3 is essentially like two binomials. We did these right here, And we basically use FOIL. So that's what we did here. So take a look at what we did. All right? 4 plus square root of 3, 5 minus square root of 3. FOIL is first, so we just take 4 times 5, and that's 20. Then we take the last. Square root of 3 positive times the square root of 3 negative. All right? What's a positive times a negative? Well, that's a negative. 3 times 3 is square root of 9 there, or the square root of 9, which is 3. So here's our first, here's our last. How do we do the middle? We do our rainbow again. So here's what we do. The outer is 4, all right? Actually, it's positive times negative, which is negative. 4, all right, times square root of 3. Remember, we keep the numbers on the outside. The radicals still stay on the inside. So 4, negative 4 square root of 3. Then we do the inner. We've got the 5 on the outside. It's positive square root 3. And notice we have square roots 3 right here, don't we? So because it's the radical that's the same, we can combine like terms. What is a negative 4 and a positive 5? Well, that's a positive 1. And we don't need to write it. And we have square root 3, and that becomes the middle. Now, that's our answer, but not final. We still have the simplification of 20 minus 3 is 17. 17 plus square root 3 is our answer. If you write square root of 3 plus 17, you can do that as well. We usually put the number there first on that particular problem. Now, that is the top part. You say, Mr. Grace, you mean all that was just the top? Yes. It's right here. I carried the 17 plus square root 3 to the top. Now we have to do the bottom. The bottom, though, isn't as hard. You know why? Because it's like our conjugate. It's just the same numbers, but a different sign. So there's no middle when we do FOIL. So all we have to do is take 5 times 5, which is 25, and a square root of 3 times the square root of 3, which is a square root of 9, which is 3, but why is it negative? It's negative because a positive times a negative is a negative. There's no middle to have to work with because these are the same numbers, just different signs. 25 minus 3 is 22, and that's the bottom, and we carried the numerator down, and that is our answer, okay? Woo! A few more steps it is, all right? Let's try this one more, and this looks like quite a mess, but I'll explain it to you. This here is the original problem, and our problem actually deals with both a radical, a number in front of it for our first term, but in our binomials, we also have that second term with just the number, okay? And we want to treat that in the right way with all of our different rules that we followed with radicals. So, in order to get that radical out of the denominator, okay, we have to do the same thing except what? Hopefully you guessed it. Same numbers, but different what? Different signs. Just like we did here. Same numbers, different signs. All right? That's how we get rid of that radical in the denominator. So I'm going to multiply the top and the bottom by 2 square root 3 minus 5. And that's going to give me, well, you can see it already, but it's going to give me a number in the denominator, not a radical, because I don't want that. And that is how I get rid of the radical. So let's do the top part. 3 square root 2 plus 4 times 2 square root 3 minus 5. Remember, we multiply top and bottom by the same. So 3 square root 2 plus 4, 2 square root 3 minus 5, and here we go. FOIL first. All right, 3 square root 2 times 2 square root 3. Well, what's 3 times 2? 6. What's square root 2 times square root 3? Square root 6. First one's done. All right, now the last. Let's do it. Positive 4 and a negative 5. What's that? Negative 20. Pretty easy. Well, now we got a rainbow, don't we? So let's do our rainbow. Let's multiply the outer, and then let's multiply the inner. Well, the outer is 3 square root 2 times negative 5. Well, 3 times a negative 5 is a negative 15, and then all we have left is square root 2. All right? Now the inner part is going to be 4 times 2 square root 3. 4 times 2 is 8, and then we've got square root 3. Do we have the same radical where we can combine? No, because square root 2, square root 3 are different, right? So here's what we do. When they're not the same and they can't be added, and sometimes that happens, here's what we do. We write 6 square root 6, which is what our first was. We carry down our minus 15 square root 2. Then we go plus 8 square root 3, and then we subtract 20. So we just write it as is. Now what I did is I wrote the first, and it kind of looked like that. Then I wrote the second, or the last, and it looked like that, and I left the middle open. And I left it wide open because I kind of knew that it was going to do that, but you got to leave room in case it doesn't. So you just write it straight across, all right? Now, square root 6, square root 2, square root 3, nothing can be combined, and I have a negative 20, I don't have another number to add it to. We're going to leave that. That box part is just the top part right here. Now we're going to do the bottom part. Remember, the bottom part's easier. No middle, just the first, just the last. Perfect square. Watch what we do, all right? We have, with this 3 square root 2 plus 4, all right, or I'm sorry, 2 square root 3 plus 5, 2 square root 3 minus 5. We multiply the first of each one. 2 square root 3 times 2 square root 3. What would that be? Well, 2 times 2 is 4. Square root 3 times square root 3 is square root 9, which is 3. Okay? So we have 4 times 3 in the first part, all right? And then plus minus, we're going to do minus, is, what's a positive 5 times a negative 5? A negative 25. So 4 times 3 is 12. 12 minus 25 is a negative 13. And this right here, all right, is the bottom part. So the top part gets carried to here, the bottom part gets carried down to here, and that whole thing is our answer, all right? Messing around with radicals can kind of be tricky. We have a whole unit on it, and right from the very get-go, it's good to familiarize yourself with all of the different rules right from the beginning as we start to basically break down radicals in our sets of 2 and 3 and 4, and then as we divide and we multiply, we even combine by adding like terms. Everything builds on everything, so you have to understand the concept. And of course, remember that in this particular case, with a couple of different problems, we don't want that radical to be in the denominator. So we always want to multiply it by the opposite of it. 5 plus square root 3 would be the 5 minus square root 3. We just change the sign, we keep the numbers the same. Trust this has been a help to you. Thank you now for listening. Take care. Bye-bye.